All right, let's dive in. If you want to write Java code that can actually survive out in the wild, there's one skill you absolutely have to nail: exception handling. And that's exactly what we're going to break down today. You've been there, right? You spend hours writing what you think is just flawless code, but then a user types their name where a number should go, or a network connection just drops. And just like that, boom, your beautiful application grinds to a halt. It crashes. That's the exact problem we're going to solve. And don't worry, we've got a roadmap for this. First, we'll figure out what's actually happening when code goes wrong. Then, we'll build a safety net for our program. After that, we'll learn how to raise our own red flags, understand the official rules of errors, and finally, get into creating our very own custom alerts. By the end of this, you're going to be in total control. Okay, first up, when code goes wrong. Before we can even think about fixing errors, we got to know what we're up against. What are these things really? So in Java, this disruptive event has a name. It's called an exception. You see, it's actually an object that Java creates the second something goes haywire. It acts like a massive error signal that just completely torpedoes the normal step-by-step flow of your program. It's basically your code throwing its hands up and yelling, "Whoa, stop everything, something is seriously wrong here." I think this is the perfect way to look at it. An exception is like a fire alarm that suddenly starts blaring. You can't just ignore it. It forces the entire program to stop what it's doing and immediately look for the emergency procedure. And what if there's no procedure? Well, the whole thing just shuts down. Game over. Okay, so how do we actually build that emergency procedure? Well, that brings us right into our second section, your program's safety net. And its main tool is the try-catch finally block. This is your bread and butter, your fundamental toolkit, and it's really just 3 simple steps. First, you're going to try out the code that you think is a little sketchy, the stuff that might fail. Second, you prepare to catch a very specific error if it happens. And third, you decide what code has to run finally, no matter what, success or failure. So let's break that down. The try block is kind of like a quarantine zone. Any code that could potentially cause an issue, reading a file that might not be there or connecting to a database that might be down, you wrap it inside these curly braces. It's like you're telling Java, hey, give this a shot, but be ready for trouble. And if that trouble does hit inside the try block, well, the program's execution immediately jumps ship. It goes straight to the catch block. This is your plan B. This is where you write the code to handle the problem. Maybe you log the error for later, or maybe you just show a nice, friendly message to the user instead of a scary crash report. And then we have the finally block. This guy is the cleanup crew. I mean, it really doesn't matter what happens. It doesn't care if the try block worked perfectly or if a catch block had to jump in and save the day. The code inside finally, it's gonna run. Always. And this is absolutely critical for some tasks. And this is why it's a huge deal. Think of finally as your code's leave no trace policy. If you open up a file or a network connection in your try block, you have to make sure it gets closed. The finally block guarantees that these resources get released, which prevents these nasty little resource leaks that can slow down and eventually crush your entire application over time. Using finally correctly is really a sign of a pro. All right, catching exceptions is one thing, but what if we need to be the one to sound the alarm? What if we need to create and signal an error ourselves? That's what we're getting into next, raising the red flag with throw and throws. Now, this is a super important distinction, so listen up. Think of it like this. Throw is the action. It's you inside a method literally creating and launching an exception into the air. Throws, on the other hand, is the warning label. It's a declaration you put on the method's signature itself, and it tells anyone else who uses your method, hey, just a heads up, this thing I built might throw an error at you, so be prepared. Yeah, it turns out not all exceptions play by the same rules, and that brings us to a really important concept in Java, the difference between checked exceptions and unchecked exceptions. So this table breaks it down really nicely. On one side, we have checked exceptions. The Java compiler itself checks for these before it even lets you run your code. It forces you to deal with them, either with a try-catch block or by declaring throws. These are usually for things outside your program's direct control, like a file not existing. On the other side, you've got unchecked exceptions. These are usually bugs, your fault, like trying to use something that's null. The compiler kind of trusts you to be a good programmer and not let those happen. So here's the bottom line. Java's system of checked exceptions is basically designed to make you a more thoughtful programmer. It forces you to stop and think,
Okay, what could possibly go wrong here when I'm dealing with this file or this network? And then it makes you write a plan for it right from the get-go.
All right, let's talk about the final piece of the puzzle, the thing that takes you from just handling errors to truly mastering them, creating your own alerts. We're talking about building custom exceptions. So you might be asking, why bother, right? Well, because getting a generic exception doesn't tell you much. But imagine you're building a banking app. An error called insufficient funds exception? Wow, that's crystal clear. It tells any other developer, or even you 6 months from now, exactly what went wrong. It makes your code so much easier to understand and maintain. And you know what? It's actually way easier than it sounds. You just create a new class, give it a meaningful name, and tell it to extend or inherit from one of Java's built-in exception classes. That's it. Just like that, you've created a custom alert that speaks the language of your specific application. And that is the real game changer. When you start making your own custom exceptions, you're not just writing code anymore. You're designing a whole system that's not only resilient, but that also explains itself when things go wrong. Your code becomes more robust, way easier to debug, and just a lot more professional. Okay, so let's do a super quick rundown of the big ideas. Number 1, use try, catch, finally as your safety net to manage errors gracefully. 2, remember that throw is the action of signaling an error, while throws is the warning label you put on a method. 3, know the difference between checked exceptions, which the compiler forces you to handle, and unchecked ones. And finally, number 4, create your own custom exceptions for super clear, specific error messages. So I want to leave you with this thought. Learning proper exception handling isn't really about just preventing your apps from crashing. It's about giving you the confidence to write bigger, more ambitious, more powerful code, because now you know how to handle it when things go wrong. So the real question is, what are you going to build now?